Yeah, good evening all. Now I would like to discuss some problems on star to delta and delta to star transformation. Okay, in this problem, first we need to calculate the equivalent resistance between A and B terminals. Okay, by seeing this circuit here, we didn't identify here whether the resistors are connected in series or parallel. Just see here, for example, assume if 8 and 4 are connected in parallel. Parallel, what is the condition? Starting end should be connected to common point, finishing end should be connected to common point. Not valid. Hence these two are not connected in parallel. Check whether these two are connected in series. No. No, current is not same here, right? Here we didn't identify whether the resistors are connected in series or parallel. Okay, then I can go for the delta to star transformation. Okay, for that purpose here you can consider either first top 3 delta or bottom 3 delta. You can consider any one. Okay na? That means if this resistor already participated in this delta, right, then this resistor again cannot participate in another delta. Hence only one delta is possible here, right? Hence here I need to consider delta. Here I am considering top one. I can represent like this. Delta to star, I am assuming R1, R2, R3, right? Then after redrawing, first you need to represent delta with star. This delta with, I am representing this delta with star. Okay, then redraw the circuit. Okay, you can remove that delta. Delta is replaced by star. Okay, or directly you can write here, no problem. Here it is 2 ohm, R1, R2, R3, 8 ohm, 4 ohm, right? First calculate R1, R2, R3. Okay, here R1 delta to star, right? Here R1. Okay, at this junction what are the elements are touching? 4 and 8, right? That is product of those two resistors, that is 4 into 8 by sum of delta connected elements, 4 plus 8. That is 32 by 16. R1 value will be 2 ohms. Okay, similarly R2 is equals to R2, right? At this junction 4 and 4, product of those two resistors, 4 into 4 by 16, sum of delta connected elements, directly I am writing 16. You will get 1 ohm. R2 value as 1 ohm. Similarly R3 is equals to 4 into 8 by, see here, 4 into 8 at this junction, product of those two resistors, that is 4 into 8 by 16. Again I will get 2 ohms. Now see here, for example, assume here total current is I, same current is flowing up to this point. Here current is divided into I1, I2. That means this I1 current, same current is flowing through this 8 ohm also, right? That means 1 and 8 are connected in series. Similarly 2 ohm and 4 ohm are connected in series. Then the equivalent circuit will be 2 ohm, 2 ohm, 2 resistors are replaced by single resistor, that is 9 ohm, and 2 resistors are connected in series, 8 plus 1 9. Okay, 2 plus 4 6 ohm, right? Next, 9 ohm and 6 ohm are connected in parallel, right? 9 into 6 by 9 plus 6 15, 3 2s are 3 5s are, right? 18 by 5. Okay, now the equivalent circuit will be here. These two resistors are replaced by single resistor AB, 2 ohm, 2 ohm, 18 by 5 approximately 3.6 ohms, right? Then the resistance between A and B terminals will be all are connected in series, right? 2 plus 2 4, 7.6 ohms. Okay, in this way we can calculate equivalent resistance between A and B terminals, okay, by using delta to star transformation. Okay, similarly we can solve another problem also. Okay, see here I need to calculate total current I. Okay, if you use nodal analysis you cannot solve. Why? Because you will get this is node potential is given, potential with respect to ground is given, no problem. But here you need to calculate node potential, node voltage VA, VB, VC, VD. If we solve we need to solve 4 equations. No method to solve the 4 equations, right? Similarly, if I use mesh analysis, loop 1, loop 2, loop 3, loop 4, again also not possible. Only one method is to solve this type of problems is star to delta transformation. See here this is one delta, this is another delta. At a time I can apply delta to star transformation. Okay, now see here, right? While representing, take careful. Okay, R1, R2, R3, right? R4, R5, R6. See here, in this way you need to represent star, delta to star transformation. Okay, then I can redraw the circuit like this. Okay, this point, all points will be common, right? R1, R2, R3, 6 ohm, another 6 ohm, okay. Can I draw like this? Okay, this delta is replaced, this delta is replaced. That is all I am done here. Okay, here minus plus 20 volts, R1, R2, R3, R4, R5, sorry, here it is R6, it is R5. Okay, R1 value is equals to R1 value 2 into 2 by 2 plus 2 plus 2, right? That is 4 by 6 ohms. R2 value, R2 2 into 2 by 2 plus 2 plus 2, again 4 by 6 ohms. Similarly R3 value will be 4 by 6 ohms, that is nothing but 2 by 3 ohms, right? Three equal values are connected in delta. The resultant star parameters will be divided by 3, 2 ohms, 2 by 3 ohms, right? This is 2 by 3 ohm, 2 by 3 ohm, 2 by 3 ohm. Similar way, directly I can written as R4 is equals to 8 by 3 ohms, R5 is equals to 8 by 3 ohms, R6 is equals to 8 by 3 ohms, right? Three equal values, delta connected values, represented by star. Okay, after that R4 value 8 by 3 ohms, 8 by 3 ohms, 8 by 3 ohms, right? Okay, now see here, 2 by 3 and 6 and 8 by 3 are connected in series. This 2 by 3 and 6 and 8 by 3 are connected in series. Then the resultant circuit will be like this. Minus plus 20 volts, right? 2 by 3 ohms. Okay, 6 plus 2 by 3 plus 8 by 3, right? LCM will be 3. 18 plus 10, 28. 28 by 3. This is also 28 by 3 and 8 by 3 ohms. Next, 28 by 3 in parallel with 28 by 3. Two equal values are connected in parallel. Resultant value will be half, right? That is 28 by 6. 28 by 6 can be written as 14 by 3 ohms, 2 by 3 ohms, 8 by 3 ohms, minus plus 20 volts, right? Then here you will get current I is equals to 20 by 2 by 3 plus 14 by 3 plus 8 by 3. If you simplify this equation, you will get the current value. Okay, this is the only one method to solve this type of problems. Okay, I hope all of you understood. Okay, thank you all.